Ever tried walking on a perfectly smooth sheet of ice? It's tough, right? That annoying thing making you slip and slide is a lack of friction. On Earth, friction is everywhere. It lets us walk, drive cars, and even hold a cup of coffee. But what happens in space, where everything is just floating? Is friction still a thing? You bet it is, and it gets weirdly hilarious. Imagine you're an astronaut. Let's call you Alex. You're floating peacefully inside the International Space Station, trying to eat some space tacos. Suddenly, you need to tighten a loose bolt on a panel across the room. On Earth, you'd just push off a wall and your shoes would grip the floor to stop you. Easy. But in space, you push off the wall, and now you're a human cannonball, hurtling towards the other side with nothing to slow you down. You can't just hit the brakes because there's no friction with the ground. You're going to slam right into that panel. Ouch. So how do astronauts deal with this? They become masters of controlled movement. They use handrails, tethers, and special shoes with grippy surfaces. But, Evan 10, things can get tricky. Let's go back to Alex. After bouncing off the panel, you finally grab onto a handrail. Now you need to turn that bolt. You'll grab your trusty space wrench and try to turn it. But here's the problem. For every action, there's an equal and opposite reaction. As you try to turn the wrench clockwise, your entire body starts spinning counterclockwise. You're not tightening a bolt. You're becoming a human gyroscope. It's Newton's third law in its most dizzying form, too. Sol Batiste astronauts have to brace themselves. They might wedge their feet under a railing or have another crewmate hold them steady. It takes teamwork just to do a simple task that would take seconds on Earth. Friction in space isn't just about stopping, it's about control. Without it, every little push or twist sends you spinning or flying. And it's not just inside the station. During a spacewalk, this gets even more critical. Spacewalkers are tethered to the station, but they still need to move around. They use a tool called a pistol grip tool, which is basically a fancy space drill. It's designed to handle high torque without spinning the astronaut into the void. The tool absorbs the rotational force, so the astronaut can work without becoming a human ballerina in a billion-dollar suit. Even something as simple as two metal surfaces touching has different friction in space. On Earth, a thin layer of air and moisture gets between objects, acting as a lubricant. In the vacuum of space, those layers are gone. If two clean flat pieces of the same metal touch, they can actually fuse together in a process called cold welding. The atoms of each piece can't tell they belong to separate objects anymore. And T-Bone,